In this lesson, we are going to learn about vertex form. The first form that we learned for a quadratic equation was standard form. That's the only one we've worked with so far this chapter. The one you see here is called vertex form. So it's y equals a times the quantity x minus h squared plus k. We're going to look at how this form, that variables a, h, and k change a parabola, so we can see kind of how they influence how we can graph it from this form. So looking at this geometer sketch pad, there's a parabola here, and you'll see that I have a, h, and k labeled, and you can see how the parabola moves based on how I move a, h, and k. So first I'm going to move a. A is the number. You'll see, hopefully you can see at the bottom of your screen it says f of x equals 1.0 times x minus 3.5 blah blah. So look in the blue, see how a is 1 right now. So as I move a and make it bigger, look what's happening to my parabola. It's getting skinnier, right? You see that it's getting skinnier. The bigger a gets, the skinnier this parabola gets. Now as I go to 0, I don't even have a real parabola here. So a actually can't be 0. It doesn't really show on the sketch pad, but look what happens as soon as it goes negative. A is positive, parabola goes up, negative, down. Positive, up, negative, down. And we've known that about a, right? That was true for standard form also. So when a is positive, my parabola goes up. When a is negative, it goes down. And when a is small, look at this as a negative 0.1. See how wide my parabola looks? So this would be like negative 1/10. My parabola, the smaller the a value, the wider it is. The larger, or in this case I suppose smaller because it's negative, but the bigger absolute value we should say, the skinnier the parabola gets. So when I'm looking at my notes, it's asking me, look at the very bottom of my screen right now, what does a determine? So we're going to say that a determines the shape and direction of the parabola. So shape and direction of parabola. If you want to make a note about how when a is bigger, it's skinnier, anything that we talked about, you feel free to add that to your notes if you think that's something you won't remember. Then we're also going to look at how h and k play roles in our parabola. So take a look back at the same one. I'm going to keep our a value at 1, so it's kind of a basic shape of a parabola. Notice that my h in green is right now at 3.5, negative 3.5 I should say. So look what happens as I'm moving that. As I move this along the axis, what's happening? H makes my parabola move left to right, doesn't it? See that? When h is a negative, let's make it negative 7, my parabola's vertex is at negative 7 on the x-axis. When h is a positive 4, the vertex of my parabola is at 4. So h is going to move my parabola left to right. And it's also going to, well, determine the x-coordinate of my vertex. So now look at my k. Now that h moved it left to right, look at k. What does k do? Up and down. See that? K moves it up and down. So when k is 3, look at my h and my k right now. What is my vertex? The vertex of this parabola right now is 4, 3. Now look at the values on my sketch pad. H is 4, k is 3. So when we're doing that, what I want you to notice is it's a little bit like point slope form. Inside that parenthesis, it says x minus h. So my formula would say x minus 4. But where is my vertex actually? At a positive 4. So in order, because the formula has a negative there, in order for it to become a positive, you'd have to substitute a negative value. So take a look at if I do this. When I'm at negative 3, it says x minus a negative 3. So we would write that as x plus 3. Sketchpad's not that smart. It can't convert that for me. So we would know that if it says x plus 3, our vertex is actually at negative 3, whatever the y value is. So in our notes, we're going to say h and k. H moves our vertex left and right. K moves our vertex up and down. And so our vertex, you'll see that spot I have for vertex up there, our vertex is actually always going to be H, K. The axis of symmetry, since that's the line that cuts our parabola in half, is going to be x equals h. So whatever that x coordinate of the vertex is. So now, the nice thing about this, why we want to learn this, is when we have a parabola or an equation in vertex form, we don't have to make a table to graph. We don't have to do negative b over 2a. All that stuff we did in 6.1, that doesn't need to happen when you're in vertex form. You can graph the parabola just from this form. So when I look at number 1, I'm going to list the vertex. Remember, my vertex is hk. So here is my a spot, here's my h, here's my k. Now this says plus 2. So that tells me I'm going to take the opposite. So my vertex is going to be negative 2, and then this says 1. I keep it the exact same. My vertex is negative 2, 1. My axis of symmetry is always x equals h, so it's x equals negative 2. And remember, that's the line that cuts that parabola in half. Direction of opening, meaning does my parabola open up or down? It opens down because my a value is negative 1. So now, instead of having to do all that work to find our vertex, we just were given it, right? I'm going to go ahead and plot this. Negative 2, 1 is my vertex. My a value is negative 1, so I know I'd go down 1, right 1, down 3, right 1, down 1, left 1, down 3, left 1. And I've just graphed this parabola much faster than I did in lesson 6.1. If you're in vertex form, it's very quick. Now remember, if you don't know this pattern here of how you move, you could just plug that in your calculator and you could get the same values. Let's try the second one. You guys go ahead and try this one and see if you can name the vertex and the a value. So again, here's my a, h, and k. Since my vertex is hk, it is 3, 2. Remember, opposite of what it says in there. My axis of symmetry then is x equals 3. My direction of opening is up because my a value is 2. So as I go to graph this, I know my vertex is at 3, 2. Since my a value is 2, I'm going to go up 2, right 1, up 6, right 1, up 2, left 1, up 6, left 1. Connect the dots. And there's my parabola. Notice this parabola is a little bit skinnier than my last one because my a value was a bigger number. Last one we're going to do for this, y equals 3 times the quantity x plus 1 squared. Here's my a, here's my h, and I have no k. So think of it as them adding a plus 0. My vertex then would be negative 1, 0, which makes my axis of symmetry x equals negative 1. My parabola opens up because my a value is positive 3. So as I graph this, I start at negative 1, 0. And when it's 3, I'm looking right here. Remember, I'm going up. Up 3, right 1. Up 9, right 1. Up 3, left 1. Up 9, left 1. Even skinnier still. Try to make yours go actually through the points. And there's my parabola. So hopefully that's a pretty good introduction for you on vertex form.